Scientists at Harvard, John A. Paulson School of Engineering and Applied Sciences, are getting closer to building robots that move almost like living creatures. A new breakthrough in 3D printing could allow robots to use artificial muscles that bend, twist, stretch, and contract in ways that look surprisingly natural. Over the years, engineers have already given robots many human-like abilities. Modern machines can see with cameras, hear with microphones, process information with advanced eye systems, and even react to touch. But creating muscles that behave like real biological muscles has been one of the toughest challenges in robotics. Human muscles are incredibly advanced. They let us perform delicate movements like painting or typing, while also giving us the strength to lift heavy objects or react instantly when something falls. Reproducing that same level of smooth, flexible movement in machines hasn't been easy. Traditional robots usually rely on electric motors, hydraulics, or air-powered systems to move. These systems work well for industrial tasks, but they tend to be rigid, bulky, and mechanical-looking. Engineers have experimented with soft robotic muscles before, using compressed air, heat-sensitive metals, special polymers, and even tendon-inspired systems. Many of them worked, but they often needed heavy support equipment, high voltages, or complicated mechanical setups. The new approach from the Harvard team takes a much cleaner and smarter route. Instead of attaching separate motors and moving parts, the researchers created artificial muscle-like filaments, where the movement is built directly into the material itself during the 3D printing process. The system uses two soft materials working together. One is an active material that changes shape when heated, while the other is a passive material that resists movement. By carefully printing these materials side by side, the researchers can control exactly how each filament behaves later on. When heat is applied, the active material tries to contract. Since the passive material pushes back against that motion, the entire filament bends, curls, twists, or coils into different shapes. The team also developed a rotating printing nozzle that programs special molecular patterns directly into the structure while it's being printed. That means a single artificial filament can be designed to spiral, shrink, stretch, tighten, or straighten without using gears, rigid joints, or extra mechanical systems. The movement is literally built into the material itself. To show what the technology could do, the researchers printed soft lattice structures and flexible filaments that transformed dramatically under heat. Some expanded, others contracted, and some flat structures even turned into dome-like shapes. In another demonstration, the team created soft robotic grippers that could lower onto objects, gently wrap around them, lift them, and release them later. This kind of technology could have huge potential in the future. The researchers believe it may lead to advanced soft robots, adaptive medical devices, smart filters, temperature-responsive structures, and shape-changing robotic systems. Since everything can be customized through 3D printing, engineers could eventually design robotic parts with movement patterns tailored for very specific tasks. Robots still have a long way to go before they fully match the smooth movement of living organisms, but this breakthrough shows just how quickly the gap is closing.